Does your Revit electrical model really need to be in 3D? What if you only need a two-dimensional CAD-style set of drawings? Well, how would you go about even doing that in Revit? Well, stick around, and in this video, I will show you step by step exactly how this can be accomplished. This may sound controversial, and personally, I embrace and even champion the amazing 3D aspects of Revit for design coordination and clash detection and presentation to help others understand our designs. And some of you may even ask, why not just continue using CAD if all you're going to do is present two-dimensional drawings? Well, I would argue that Revit, or BIM in general, Building Information Modeling, has so many advantages over CAD, even in just a two-dimensional setting, that you really need to scrap that old CAD and move on. Yes, the three-dimensional part of Revit gets a lot of coverage. It's the new thing, the sexy, the glamorous part of design right now, and it's very useful. But let's get real. In the electrical end of things, for many of us, the information within the model is the most important part. The field of electrical engineering and design, even just in the construction industry, has a broad spectrum of niches and different ways that we can present our documents. So I believe that Revit can be tailored to wherever you fall within that spectrum. Even when I was first adopting Revit for our firm over 10 years ago, I did a lot of two-dimensional only models. And even today, some of the simpler projects only need that level of detail. So even though we were originally doing 2D only, why did we ditch CAD? Because I decided early on, why try to keep two different programs up to date with details and templates and symbols? Just move on to Revit, even if only using 2D at first. So as you progress in your learning, and as more of your clients request it, you can slowly move into the world of 3D. Now, the easy first step is using drafting or legend views that are obviously just a two-dimensional drawing, like a one-line diagram or details or a symbol list. I have videos on my channel which show you how to create these two-dimensional symbol-type families for use in one-line diagrams that have smart labels and some on and off graphics, which I have linked in the description below, realizing that out of the box, Revit doesn't even include any of those symbols. However, when it comes to the floor plans and reflected ceiling plans, the out-of-the-box Revit families are typically three-dimensional and some have a two-dimensional symbol, but they're typically hosted or forced to be attached to some 3D geometry like in a linked architectural model that has walls, floors, and ceilings. So Revit itself seems to be very much pushing us to adopt the 3D modeling. But if your particular design scope only needs a two-dimensional drawing, you don't actually need any 3D. I mean, your effort has to match your scope and fee, right? And many times you may be working with a strictly CAD type of background. I mean, believe it or not every architect is on Revit either. So having these three-dimensional electrical families with forced hosting is actually hindering you. And furthermore, starting out with 2D only is a great way to ease into Revit from CAD. Now, I already do have videos on my channel showing you how you can create custom content for non-hosted families, which could be used in this case, but they do still have a 3D element in them. You just don't have to use that part. So all that being said, let's see what it would take to go one step further to create two-dimensional only symbols, which I would call smart symbols, that are only 2D, but can still be connected together to form an intelligent electrical system. And you may be new to the family editor, but don't be intimidated by it. Creating these smart symbols is very similar to just creating blocks in CAD. And it's actually a great way to dip your toe into family creation. So let's get right into it. So I'm here in Revit 2024, and this is an electrical floor plan that is purely two-dimensional. It looks like any other floor plan, even the ones we do in 3D. But if I click on this, you'll notice this floor plan is a CAD. It says imported symbol, and it's just a DWG. And in Revit, you can bring in a CAD background. You can link it in like a model, but just link in CAD. And I can turn on and off the layers from going to the query up here clicking on something like this door, and it will tell me what layer it's on, a door, and I can hide that if I want. So I've gone through and hidden some of the dimensions and things like that. So this is an example of just a two-dimensional drawing. I don't need any 3D coordination in this one. This receptacle is purely two-dimensional. This connection is my motor and disconnect that I show in another video, which I'll link below. And it is purely a two-dimensional symbol with some smarts to it. So you can apply that scheme to other pieces of equipment. This panel, for example, believe it or not, this is just a two-dimensional symbol. There is no 3D panel tub or anything like that here. But it has all of the electrical loads and electrical connections and distribution type and everything that the three-dimensional panels have. So let me show you how I created this symbol-only panel in the family editor. Now again, you could use a non-hosted panel the same way, but I want to do this as an example to show you that 3D is not required in these families for them to work. Now, one thing to note about a panel board is the symbol for it should get larger and smaller as I change its dimensions, and it should stay appropriately scaled to the drawing. Unlike this symbol, which will always be like an 1/8 inch circle and an 1/8 inch square, no matter what scale it's in. So you have to realize there's annotative symbols and then there's scaled symbols. So this is a scaled symbol. Let's jump right into the editor. Let us go up to the File, New, Family, and it jumps us typically into the family templates. So we are going to create an electrical equipment right here. And you can see that it doesn't say it's ceiling based or wall based or anything like that. It is just floating, non-hosted, which is what we want. Now we go electrical equipment because that will set up the behind the scenes information that a panel needs. So as you can see over on the right, it's a mechanical part type panel board. And that means that if you go to the family types, it already has the panel board style parameters, feed through lugs, neutral ratings, main circuit breaker, all the panel stuff that we need. So we can connect branch circuits to it from downstream. Now we will still need to add an electrical connector to connect this panel upstream, but we will get to that in a minute. First, we just want to get the symbol drawn. And we're going to draw that symbol right here in this family because we want it to be scaled. So what I would do is just simply create a two-dimensional box. Here's the sides, and I'm using reference planes. If you're new to the family editor, we use reference planes up here. They're a two-dimensional plane that extends in all directions. So that's kind of the box of our panel. And then we want to set up some dimensions to constrain this thing. And we want to dimension these reference planes. So up in the quick access toolbar, aligned dimension, we're going to go from this dimension to that dimension. And you can move it anywhere you want, click somewhere off of here. And furthermore, we can name this so that we can easily change it within our model. So we are going to give this dimension a label and a parameter. So up here under label, we're going to go to create parameter. And we will call this panel width. It's going to be a type parameter so that every panel of this type will be the same dimensions. And we're going to group it under the dimension heading, which will show up here in your list. So if you go over to dimensions, here's panel width that we just added. So we can change it from here. Let's make it 20 inches wide. So that's 20 inches wide. Now, these initial reference planes are built in as center, left, right, and center, front, and back, because we're looking at a top view right now of this panel, plan view, if you will. So this is the insertion point where these intersect. This is the back of the panel, and the panel is going to be sticking out down this way. This is the front over here. That's the intersection point. So I want this panel centered on that intersection point. And a way to add centering is to add more dimensions. Click there, click the center, click this, anywhere off of here, and then hit the little EQ button here for equal. It will make these dimensions equal, and you can see that it changed my width. But it forced them to be equal about the center, which ends up effectively centering it. So now I can change the panel width here or in the type parameters, and let's set it back to 20 inches. Now it's centered. As you can see, as I move this around, it stays centered. Undo that. Now the panel depth. Let's get a depth dimension up here, a line dimension. Start here, go there, and click on here. Let's create a parameter called panel depth. It's a type, and it's under dimensions heading again. And we can set that to, let's set it to 6 inches. Now we're drawing a surface panel board in this case. We're going to treat that line as the mounting surface. It won't be hosted to that surface, which means we can move it anywhere we want. And it doesn't require a 3D architectural background. That's the basics of our panel. We don't need a height because we're not doing a 3-dimensional panel. Now we can just draw some symbol lines on top of this. So under Annotate, Symbolic Lines right here, click on that. Now it's going to put those symbolic lines under the electrical equipment category, which is fine. So use the line tool, and we are just going to draw lines around here. Now you can also use the rectangle tool, and it'll snap to the corner there, and then the other corner will snap here. Now once it's done snapping, you will see the little padlocks show up. That's asking if I want to padlock that line to this reference plane, which I do. I want it attached to that plane, so as I move the plane, the line goes with it. So let's lock it back of the panel, to the left of the panel, to the face of the panel, and to the right side of the panel. So that's locked, and we're done there. So hit escape. Now, as I move these, the black lines go with it. And we can just flex the model, test the model to make sure it works. Now, that's all we really need for a panel. If you like a few more lines and your symbol, we can do that easily. And I like a few more lines in here to make it kind of pop in my drawing. I like it to be kind of bold, but I don't make it solid. Something we've brought over from many years of doing this is just a couple more lines in here to help it stand out. Now I want all these lines to be equal, so I can go back to my dimensions, and let's hit all of these. And the dimension doesn't matter as long as I hit EQ. Now they're all spaced evenly, and I want some more lines. Now I can't do create similar from here, so I have to go up to Annotate, Symbolic Line. I'm using lines this time. I'm going to go from here and it snaps to the end, and go here and it snaps. Now, as you can see, all these locks show up. Well, it's because lines get automatically attached to each other in kind of a chain of lines. So it's showing the boundary, but also it's showing one unlocked because the new line I put in, I want to actually lock to that reference plane that I drew. So let's lock it also. And then I'll do one more line here. And again, it presents a lock so I can lock it. So there. Now, one more piece I like to add, and this gets kind of fancy, I guess, is kind of like a door on my symbol to really emphasize the face of the panel. So now again, the behavior of lines is once I attach them, they're attached to each other. So what I can actually do in this case is just go to Annotate, Symbolic Line. Let me just draw this panel door. And as long as it's attached here, it will always be attached. So there. Now, as I increase the depth of my panel, that line moves with it. Or if I increase the width of the panel, the line moves with it. So we're all good there. So there. Now I only have one last piece. This is a very simple model. One last piece, and I need an electrical connector so that I can connect this panel upstream, the electrical connectors for upstream connections, to another panel or a switchboard or even to a transformer, something to feed it. So let's go to Create, and right here under the connectors is the electrical connector. So I click on that, and it has the smarts of voltage and phase and things like that. Now, by default, it wants to put it on a face of geometry. Well, I have no geometry, no 3D extrusions or anything to attach this to. So how do I attach it? Well, you can attach it to a work plane. So click on work plane, and it will give you a list of work planes. Now, a work plane would be like a reference plane or a reference level. So I have three. I have my reference level, I have and two other reference planes, front, back, left, right. I can attach it to any of these. But let's just go with the reference level and say, okay. And there, it attached it to the reference level. That big circle with the plus is the electrical connector. Now, right now, as you can see, here's the electrical connector parameters. And we have what kind of system, is it balanced or not, number of poles, lagging, is there a load classification, voltages and things like that. If I leave it like this, then I can only change these parameters inside this family editor. And I don't want that. I want to be able to change these parameters in my actual electrical floor plan, in my model. So I need to associate these parameters with a type parameter, so it shows up in this list. So the way you do that, click on the connector, and first of all, I leave it unbalanced because this is not a load. This is a distribution system, so it is typically going to be unbalanced loads going through this. Number of poles, I want to start off with, I want the voltage to be presented. So first of all, I'm going to set a default. Now, I'm setting the 3-phase voltage here because I'm going to set the number of poles to 3. So I'm making the default panel a 208 volt, ends up being a 120 208 3-phase panel. Again, I can change this in my model. I can create even a single-phase 208 with 2 poles, or I can create a single-phase 120 240. I can do whatever I want with this thing. I'm making this panel universal. I can even change it to a 480 volt panel. But I'm going to map or associate. In the far right, this teeny little box called Associate Family Parameter. I'm going to associate the voltage with a family parameter, and I don't have any in here, so I'm going to create one down here, new parameter, and I'm going to call this panel voltage. It's going to be type, and I want this under a heading called just electrical. There's a lot of different electrical headings, but I want just electrical. And say OK. That under here, family types created under electrical, panel voltage. Now you see this other voltage here and wattage? These are built in, and in newer versions of Revit like 2025, it says voltage comment, wattage comment, because these are just text. You can just put ABC in here. They have no units. They are just text. So these are really not really useful to us. So we need the actual voltage parameter. What else? We want the number of poles to be mapped or associated. So let's go ahead and click new parameter for here and call this panel poles. And I'm putting panel in front of it just so it's obvious that what we're talking about. And it wants to put it under engineering. Let's put it just under electrical so it's up there with the other one. And again, go under my family types. There it is. Poles and voltage show up here. Okay, so that is all we really need to map for a panel, because the rest of this, all the apparent loads for all the phases, the load classifications, all that will be brought in from all of the downstream loads that we attach to it. So this is different than just a piece of equipment like a load. So that's all we need to reflect is those two items. So we are done. We can save this and save as. Now, I already have one saved, but I like to give it an ER for electric Rob to show that it's custom. And I can just call this 2D panelboard. I'm just calling it 2-dimensional to remind me that there's no 3 dimensions in this. 2D panelboard, and I'll call it surface. That way I'll have 2 different ones, one for surface, one for recessed, because they have different graphics. The recessed will have a larger panel face, but I can use it for either one. Options, I only need one backup, and say save. So now I've created a panel, and let's go ahead and load it into our project. We want to save everything. And I already had one in here, so it overwrote. But now we can get to it. You can see I have a couple different versions of it. But I can get to my, this is the lighting plan. Let's go to first floor power. And let's get rid of the one I put in already. If I go to my new 2D panelboard surface and drag it in, you can see that it's not needing any kind of 3D wall. If you did this with a 3D panel, you could not just mount it out here in the middle of nowhere. You would have to have a 3D wall, and I don't. This is just CAD. But as you can see, it kind of tries to snap to a wall surface. Or if I want to go recessed, I can do something like this. So I'm free to put this panel. I can turn it around with a space bar. And let's just say I put it as let's say I use it as a recessed. Something like that. I can go in now. I have all of my normal panel board parameters. One thing I have to set, now the distribution is already set to 122.08, but if it wasn't, I could easily set that because it knows it's 208. And I can get to that voltage here under edit type. Here, I have panel voltage. I can change this to a 240 volt. So it's going to be 2 poles, single phase, but 2 poles. There we go. And then if I have 12240 single phase in my model, then I can go down and there, it set the distribution system up. It notices that it's a 12240 volt single. So now I can connect these pieces of equipment to that panel. And it's only 2 dimensions. So you can see that you can just create 2-dimensional symbols that have all the smarts needed to interconnect them without a 3D element. If you want to see more family creation for these unhosted families, take a look at this video that popped up on the screen below. And thanks for watching. Until the next one.